Now we will see the deletion of a node. Till now we have seen the insertion operation in a single linked list. Now we are going to see the deletion operation in a single linked list. And one more primitive operation that can be done in a single linked list is the deletion of a node. And here the memory is to be released for the node to be deleted. In the insertion, we have seen that how the memory is allocated dynamically. Now, if there is no use of that particular node, means I can delete that one. I can deallocate the memory by using a keyword free. That one we will see in the coding part. A node can be deleted from the list from 3 different places, namely again how we have inserted in a 3 different ways. In the same way, we are going to see the deletion also in 3 different places. That is deleting a node at the beginning, deleting a node at the end, and deleting the node at the intermediate position. Okay, again, these are the 3 different deletions from a node. First, we will see the deleting a node at the beginning. This is our linked list. Now, my task is, I want to delete a node at the beginning. I want to delete the node at the beginning. This one must be deleted. How can I do that one means, here we are discussing the deleting a node is nothing but I need to deallocate the memory. How can I deallocate the memory means by using a keyword free. And if you observe this one, I cannot directly delete it. What I have to do? This start pointer should point to the second one. Instead of pointing to the first one, I should point to the second element. But where is the second element address? It is there in the first one, next part. This is the first address, right? In the first address, in the next part, I have the address. If I replace this start with the 200, then it is possible. Then I can deallocate the memory. Now we are going to see the same thing here. See, temp. First, we are going to take the one extra pointer. Why? Because I need to deallocate the memory, right? I need to remove that memory. So, definitely we require the one more pointer, that is a temp pointer. And initially, the temp value will be same as that of the start pointer, that is 100. Now, start equal to start next. I need this address, right? How can I get this address? Already in the start, I have the 100. Now come to the 100. In the 100 next, I have the 200. Now replace this start with the 200 address. That's it. The problem is solved. After that, directly I can write the free of temp. Now when I write this free of temp, what happens here means the memory will be deallocated. The memory will be deallocated. Now the deletion at the beginning is completed. This is a simple thing. The next one is we need to delete a node at the beginning. So first, how the algorithm must be written here means, first if the list is empty, then I should display list is empty. If the list is not empty means I can replace this first element address, next address with that particular address. See, temp equal to start equal to start next, and free of the temp, whatever we have discussed, this one, these 3 lines are important to delete the beginning. And this is a complete code for the deletion at the beginning. First, what I have said that I need to declare, I need to one extra pointer, that is a temp pointer to deallocate the memory. That's why we are writing struct node pointer temp. After that, if head equal to null means the list is empty. How can I say that list is empty? If the start pointer is null, then nothing is there. There is no linked list at all to print it. So we are going to print number of nodes. No nodes are exist. And a return statement will help you to come out of this function. Then I won't come to the else part as well. Directly after reading this return, I'll come out of the function. Or else if the head is not equals to null, which means that I have some values. Then what I have to do? I need to start temp equal to the head pointer. After that, I should replace that head with the head next value and free of temp, deallocate the memory. Then we are successfully, node is deleted. This is a code algorithm for the deleting a node at the beginning. Now we are going to see how to continue the same program. In the previous classes, we have seen the void insertion at the begin. After that, to the same program we have added insertion at the end, and then we have added insertion at the specified position. Now to the same program, let us add this deletion at the beginning also. Done. We will see that. Yes. In the previous classes, we have seen about the insertion functions. Insertion at the position we have seen, insertion at the end we have seen, and insertion at the beginning. We have seen all these three functions in a single linked list we have seen. Now we need to start about the deletion operation. Just now we have discussed how to perform the deletion operation at the beginning in a single linked list, right? So before starting the main program, I would like to start void deletion at the begin function. At begin function, and in order to delete an element we need not pass any parameters, so we are directly defining the function without any argument here. Yes, and the function name we have mentioned here is deletion at the begin. So for this one, what I required one extra temp pointer. Why? Because I need to store the one and I need to deallocate the memory by using the free command, right? So here I required one extra pointer. For that purpose, I'm creating the memory for that pointer, struct node pointer temp, and which will be initially pointing to the head value. Both head pointer and the temp pointer are pointing to the first node. Done. Now our task is I need to delete at the begin, which means that here the first element should be deleted and the second element should be placed as the first one. For that purpose, directly I can write head equal to head next. And this one will be done. After that, I can write free of temp. Yes. All this can happen if the head is not equals to null. Yes or no? If head is not equals to null, then only it will happen. If head equal to null, what happens? If head equal to null means I should display that the list is empty. Is empty. Slasher. Done. And after this, I should leave the function. So return statement. Done. Or else. Only in the else part we are going to work this. And after freed, I'm just going to print that node is deleted successfully. Is deleted. Slasher. Done. This is about the void deletion at the begin function. Now I have just defined the deletion at the begin function. Now I need to call even that function, right? So for that purpose, first I need to make my choice. For first case, if I press the 1, the insert begin will start. If I press 2, display will start. 3 means insert at the end. 4 means insert at the position. Now I need to start for the deletion at the begin. To delete at begin. Slash n. I need to choose the option 5. Now again switch. Case 1, 2, 3, 4 are completed. Next I need to start case 5. Case 5. Done. Here directly I can call delete at begin function, and after that write the break statement. Okay, let us save the program by pressing F2. Compile the program. No errors. Now again run the code. Done. First, if I have any value, then only I can perform the deletion operation, right? So let me continue with the option 1 and let me add the values 23. Next, again, let me go with the third option to insert the values at the end and give the option 54. Done. Now let me go with the choice 2. Let them delete, display the values. Yes, 23, 54. Done, right? Now I want to perform the deletion at the begin. So I'll choose option 5. So what should happen if I press the 5? The value 23 must be deleted. Yes, node is deleted. It is showing that node is deleted. Again, let me print the values and check it whether it is deleted successfully or not. Yes, observe here. 23 got deleted, which means that deletion at the begin function has performed successfully. Done.